Hi guys, welcome back. So we will continue with the exercises for object-oriented programming in JavaScript. Don't forget to subscribe and let's get started right away. So we're going to learn about inheritance in JavaScript. Okay, so the reason we need inheritance, of course, is that we don't have to repeat ourselves, so to write duplicate code. Let's see here. We have the describe method, which is shared by the bird and the dog. So the describe method is repeated in two places. We can edit this code by creating a super type or parent called animal. So the animal prototype can have the describe function. We can just remove it from bird and dog. So we can use the describe function in the animal prototype. Okay, so we need to do something like this for our exercise right here. The it method is repeated in both cat and bear. So I'm going to remove this and I'm just going to put it in the animal prototype like this. Okay, so it is a function. Okay, now we need to remove it from bear as well. So we have bear prototype and cat prototype. Okay, so that's it for this exercise. Let's see. Okay, let's continue with the next. So we need to inherit behaviors from supertype. So we created a supertype called animal and we defined behaviors shared by all animals like it. Okay, so how to reuse animals method inside bird and dog without defining them again. So we're going to use inheritance. Let's create an instance of animal. And now okay, so this is the best approach to do inheritance in JavaScript. So we need to create the animal object like this, object.create animal.prototype. So we create a new object and set object as the new object's prototype. Okay, so by setting the prototype of animal to be the animal's prototype, we are effectively giving the animal instance the same recipe as any other instance of animal. Okay, so now animal has the it method, and if we do instance of animal, it should return true. So we need to use object.create to make two instances of animal named duck and beagle. So let's do this. This is going to be an object.create animal.prototype, and the same for beagle. Let's run this. Okay, great. Now we need to set the child's prototype to an instance of the parent. Okay, so in the previous challenge we saw the first step for inheriting behavior. Okay, making an instance of a new instance of animal. Now the next step, set the prototype of the subtype or child, in this case bird, to be an instance of animal. So we can do it like this. Bird.prototype is object.create animal.prototype. Okay, so we can do, and then later on when we create an instance of bird like this using the constructor, then it will have the it method, which is defined in animal. Okay, we need to modify the code now so that the instance of dog inherit from animal, and we're going to do it like this. So dog.prototype, we have already defined the function dog here, the constructor. Okay, dog.prototype is going to be object dog.create animal.prototype. And now this if we use this dog constructor, for example, for making the beagle, then beagle will have the method it. Okay, let's run this. Okay, now how to reset an inherited constructor property. So when we have an object that inherits its prototype from another object, it also inherits the supertype's constructor property. Let's see an example. We have this bird constructor. The prototype of this bird is animal. We create a duck, which is we're using the bird constructor, and of course the duck constructor will be in this case animal. Okay, but duck and all instances of bird should have should show that they were constructed by bird and not animal. So we can manually set the bird's constructor property to the bird object. So this is what we need to do. Okay, so and not use so it doesn't give us the constructor that was inherited the animal. We need to fix the duck.constructor and beagle.constructor return it so that they return their respective constructors. Let's see. We can do it like this. Bird.prototype.constructor is going to be bird, and dog.prototype.constructor is going to be dog. Okay, that's all we need to do, I think. Okay, great. So, how to add methods after inheritance. Now we can also add methods after inheritance. For example, a constructor function that inherits its prototype object from a supertype constructor function can still have its own methods. Okay, so bird is a constructor that inherits its prototype from animal. In addition to what it's inherited, we can add the behavior that is unique to bird objects. So bird will get a fly function. Okay, we can do it like this. We define this method fly. So if you create a new bird now, it will also have eat and fly. Now we need to add code to the code object, to the dog object, which inherits from animal, and the dog's prototype constructor is set to dog. So let's add the bark method to the dog object so that the beagle can both eat and bark. Okay, let's do this. So we have so the dog object should inherit from animal, and we can do that with something like this. Dog.prototype is going to be object.create and animal.prototype. Okay, and now we need to set the prototype constructor. Dog.prototype constructor is going to be dog. And now we can add the method fly, which is going to be dog.prototype.fly is going to be a function, and it just console.log, and we need to say bark, not fly. And it should say woof. Let's write it. Okay, I think this one should do it. Let's see. Dog.proto. Okay, let's run. Okay, great. Okay, now how to override inherited methods. Okay, so we learned how objects can inherit its behavior by referencing its prototype, also how to add methods, but we can also override methods just in the way that we can create new ones. For example, here we have this animal which has the animal prototype has an it method, and then we can create the bird prototype inherits from animal prototype, but here we override the it function. Okay, so if we create an instance of bird duck and we call duck.eat, this is how JavaScript looks for the method. Okay, is it defined here? No. In the duck, no. In the duck variable, no. So we go check. In the duck object, it's not defined. We go check in the bird constructor and prototype. If it is defined there, then yes, execute it. Okay. Animal it is also defined, but JavaScript stopped searching before reaching this level. Okay. Also at object level, the JavaScript had already stopped searching. We need to override the fly method for penguin so that it returns, alas, this is a flightless bird. Okay, so we have this bird prototype with a fly method here. Now we have a penguin constructor. The penguin prototype inherits from the bird prototype. Okay, now we need to override it, and we can do something like this. Let's leave it for the end. So penguin dot prototype dot fly is going to be a function which returns. Okay, so I think this is all we need to do. Let's put some semicolon. Okay, great. Now, how to use a mixin to add common behavior between unrelated objects. Okay, so behavior is shared through inheritance. We've already seen that. But some cases when inheritance is not the best solution, for example, like a bird and an airplane, they can both fly, but a bird is not a type of airplane and vice versa. So for these cases, we can use mixins. So a mixin allows other objects to use a collection of functions. Okay, so we can define a mixin like this. This is a fly mixin, which is a function, and it prints flying. Okay. So the fly mixin takes any object and gives it the fly method. So let's say we have here the object bird and plane, and we can give them as input to the fly mixin, and it gives them the method. So now we can execute bird.fly and plane.fly. Okay, let's create a mixin called glide mixin that defines a method named glide. Okay, let's glide mixin. Okay, it can be something like this, be a function, and it takes an object. So object.glide is going to be a function, and it should return. Let's see what it should return. Okay. Let's just return. Let's console log gliding. Okay. And now we need to give both. So glide mixin. It can take bird and glide mixin both. So now they both have the method glide. Okay, let's run this. Yep, that's it. Okay, now how to use the closure to protect properties. So in the previous challenge, bird had a public property name. Okay, it is considered public because it can be accessed and changed outside of bird's definition, like this. So any part of the code can easily change the name of bird to any value. Okay, so this could cause a lot of issues, especially when we have properties like passwords and bank accounts. The simplest way to make this public property private is by creating a variable within the constructor function. Okay, so this changes the scope of that variable to be within the constructor function versus available globally. So this way the variable can only be accessed and changed by methods also within the constructor function. So here is the example. We have this bird constructor and we define this variable hatched egg equal to 10, and this is a private variable because it is declared inside this constructor. And now we create this function, this getter function, get hatched egg count, which returns hatched egg. Okay, so this is a privileged method because it has access to the private variable hatched egg. This works because in JavaScript a function always has access to the context in which it was created. So this is closure. Now we need to change how weight is declared in the bird function. So it is a private variable, and then create a method getWeight that returns the value of weight 15. Okay, I'm going to create weight like this. Okay, then we need to create a method getWeight that returns the value. This.getWeight is going to be a function which returns weight. Okay, I think this should do it. Perfect. Now, how to understand the immediately invoked function expression, Iife. Okay, so a common pattern in JavaScript is to execute a function as soon as it is declared. So here we have this function, and we have defined it right here, and then we are up to here is the function definition, and then we are invoking it using the parentheses. Okay, so the function has no name and it is not stored in a variable. That means that we are just invoking it as soon as we have declared it. So this pattern is the Iife, immediately invoked function expression. We need to rewrite make nest and remove its call, so instead it's an anonymous immediately invoked function expression. So let's make it like this. Okay, so let's put it all in the brackets, and I'm going to delete this. Okay, this one should do it. Yep. It should be anonymous, so we must delete the name. Okay, yes. So now we need to use an Iife to create a module. Okay, this is what Iife is used for mostly, is to group related functionality into a single object or module. So, for example, in an earlier challenge we defined two mixins, glide mixin right here and fly mixin. We can group these mixins into a module as follows. So here is the motion module. We have a function, which this function just returns the mixins. Okay, and we immediately invoked it. So it's immediately invoked and returns an object motion module. So this returned object contains all of the mixin behaviors as properties of the object. The advantage of the module pattern is that all of the motion behaviors can be packaged into a single object that can be used by other parts of your code. So here is how we can use it: motion module.glide mixin duck, and then we can do duck.glide. Now we need to create a module named fun module to wrap the two mixins, isCuteMixin and singMixin, and fun module should return an object. So we can do it like this. Let's start declaring right here. Let fun module, and this is going to be a function which needs to be declared. Okay, it's a function, and in here we do a return, and the return will be an object, and inside the object we should have glide mixin and fly mixin as properties. So let's copy this and put it in here. So let's change this stuff right here because it needs to be an object. Okay, and it should return true. Okay, now this one is the first property, and this one is the second, singMixin. Okay, this one just console logs something. And this one we don't need. Okay, so I think this one should do it. Let's see. We might have some typo right here, but let's check first. Oh, that does it. Yeah. Okay, so that was it for object-oriented programming. We will finish this video right here, and don't forget to like, share, subscribe to support the channel. In the next one, we will continue with functional programming. Thank you for watching. I'll see you in the next one. Bye bye.